Number 14 was coming from analysis, the part of analysis, but specifically that part is called differentiation. Now, if you want a full topic about differentiation, visit the playlist. You will see the differentiation as a topic there with over 50 videos. So this one it says differentiate this with respect to x. So that's part A. Given this and this, find d squared y in terms of t in the simplest form. So let me first handle part A. Part A now, you can use the quotient rule, but it's always easier to use, by the way, natural logarithm. So if I let this function be y, I introduce natural log both sides. After introducing natural log both sides, then I can apply the properties of logarithms. Then I also apply this property that this power comes there, so that I can come something like this. Now we differentiate throughout, but this is the function of y. So to differentiate natural log, I say differentiate this over the original. So 1 over y, dy dx. This one, differentiate this, we get 2x over the original function. This is how we differentiate natural logarithm. Minus 3 into, differentiate this, we get 1 over the original function there. Now from there, we just cross multiply and also take y this side. So this comes there. The whole thing over this and this. Then I multiply y this side and multiply y the other side. So there I'll be having just dy dx. Now from there, we open brackets. You be careful. 2x squared 2 times 2x times 1, you get that. Minus 3x squared. Don't forget this, minus 3. The whole over. Then times ry. Remember, ry was relating here, you see. I put it there, x squared. The whole power 3. So that now this goes with this. Then we just simplify the upper thing. This minus this, you get minus x squared plus 2x minus 3 over. These two can multiply, have x plus 1. This, add the powers to get x power 4. So that's how I can differentiate this. You see, this one I can't simplify it any further because this will give me an area of roots. When I come to part B they gave me x, they want dy dx. So to get this, you see that these are implicit functions. We have y, t, and x. So my x, you can see my first x is 3t over. This one now becomes my u, this one becomes my v. So using the quotient rule, I have now my dx dt as v. Then we differentiate u, then minus u. Then we differentiate this one, we get 1. The whole thing over this squared, t plus 3, the whole squared. When you simplify that, you see here we shall be having 3t plus 9 minus 3t, the whole over t plus 3, the whole squared. So from here, the x dt is going to be 9 over t plus 3, the whole squared. Now from there, we get the one for y. It's that our y is going to be 4t plus 1 over t minus 2. This is my u, this is my v. Still using the quotient rule. I can get now my dy. From here I can get my dy dt as my v into, and after this I get 4 minus my u. And after this I get a 1. The whole thing over this squared, t minus 1, the whole squared. And so when you simplify that, we shall get 40 minus 40, which will cancel. And then from there, you see that we shall get negative 9. This negative 8 minus 1, the whole over t, minus 1, the whole t. This is minus 2, the whole squared. 2 minus the whole squared. Now, if I want to get now my dy dx, I'll get dy dt times dt dx. Now this will be my dy dt. You can look at my dy dt from here. It's negative 9 over t minus 2 the whole squared. Now times dt dx. I get now the reciprocal of this, which will be now t plus 3 squared over 9. And clearly, you see that now our dy dx is going to be negative into now t plus 3 squared over t minus 2 squared. Now from there, you can differentiate this now using the idea that now if I want to get my d squared dy dx, now you see this one, we want to get the second derivative with respect to x, but this one is in terms of t. So this one we handle it by saying I will get d, I differentiate, I respect the function which is there, or the function we have, the whole over t minus 2, the whole squared. But now we need the dx down, so times dt dx in that order. So now from there, let us differentiate. I am going to first put this negative out into, now this is my v, t minus 2 squared. Differentiate this now, we shall get 2 into 2 plus 3 into 1. I'm putting this negative out, then minus u, which is 2 plus 3 squared. Now when we differentiate this, we get, I think it's that we shall get our 2 there, 2 into t minus 2. The whole thing, we are multiplying with our dt dx. Our dt dx from here, the reciprocal there, which is t plus 3 squared, the whole over 9. The whole thing, now when we square this v, we get t minus 2. Now this one gets us to power 4 when we square that one. Now there we had to just simplify. You see 2, these two brackets are common, they are common there, and this 2 is also common. So if I factor out 2 into t minus 2, then 2 plus 3, I remain with, here I remain with, remember I'm removing this out, and then one of these ones I have my 1 minus 2. This is into big brackets. Then here I remain the negative, remove this, and one of this I remain with t plus 3. The whole thing now, remember I have 2 plus 3 squared there. The whole thing over, this my 9 comes there, to multiply that in that order. So simplifying that, you see that we have minus 2. I think you see one of these ones goes, I mean here with 3 of them. So I have 2 plus 3. Now, into, this will give me, I think you see minus to go. So I'll have negative 5 remaining there into 2 plus 3 power 2. The whole thing over 9 into 2 minus 2 power 3. Now you see, minus and minus to get me 10 into, now t plus 3 power 3, the whole over 9 into t minus 2 power 3. Remember the question said, in the simplest form. So I can simplify this because you see, we have the same power. So my d squared dy, dx squared can be 10 over 9. Now I can put these two at once in one bracket, t minus 2, the whole power 3. So that's how far I can simplify that number in terms of t. So that's how we handle that one, members. I wish you well. If you want a full topic about differentiation, please visit my playlist, and please don't forget to subscribe to the channel. That's it. I wish you well.